Welcome back to Quantum Vision. I am Dr. Emar, your guide to exploring the fascinating world of quantum computing. Today, we'll dive into how qubits work and the incredible possibilities they unlock. Let's get started. We stand on the precipice of a technological revolution. Just as the transistor transformed the 20th century, the qubit is poised to redefine the 21st. Qubits are the building blocks of quantum computers. They hold the key to solving problems that are impossible for even the most powerful classical computers today. Imagine a future with unbreakable encryption, life-saving drugs designed at lightning speed, and artificial intelligence that surpasses human comprehension. This is the promise of qubits. To understand the power of qubits, we must first grasp the limitations of their predecessors, bits. Classical computers use bits, which can exist in one of two states, 0 or 1. Like a light switch that is either on or off, a bit state is binary. Qubits, however, operates by the strange rules of quantum mechanics. They can exist in a superposition, simultaneously representing both 0 and 1. This fundamental difference is what grants quantum computers their incredible power. Imagine a coin spinning in the air, neither heads nor tails, but a blur of both possibilities. That's superposition in action. A qubit in superposition is like that coin, holding both 0 and 1 states simultaneously. This allows quantum computers to perform calculations on multiple possibilities at once. It's like exploring every path in a maze simultaneously, instead of taking them one at a time. This ability to explore many possibilities at once is what makes quantum computation so powerful. Entanglement is where quantum mechanics gets truly bizarre. When two qubits become entangled, they share a mysterious connection. Measuring the state of one instantly determines the state of the other, no matter how far apart they are. It's as if two coins, flipped miles apart, always land on the same side. This spooky action at a distance, as Einstein called it, is crucial for quantum computing, enabling complex calculations and information transfer. Albert Einstein, one of the founding fathers of quantum mechanics, famously referred to this phenomenon as spooky action at a distance. Despite his skepticism, Einstein's work laid the groundwork for much of modern quantum theory, influencing the development of quantum computing. Quantum computing and AI, a powerful synergy. In 2024 alone, we've witnessed the incredible synergy between quantum computing and artificial intelligence. Complex AI models, once limited by classical computers, are now being turbocharged by qubits. This has led to breakthroughs in drug discovery, material science, and even our understanding of the universe itself. Quantum computers are accelerating AI's learning process, paving the way for a future where AI can tackle problems that were once thought impossible. Qubits at work, revolutionizing industries. The potential applications of qubits span across countless industries. In healthcare, quantum computers could design personalized treatments, leading to cures for diseases like cancer and Alzheimer's. In finance, they could optimize investment strategies and manage risk with unprecedented accuracy. And in robotics, they could enable machines to learn and adapt to complex environments with human-like intelligence. Qubits are poised to revolutionize the world as we know it. The quantum shield, unbreakable encryption. As our world becomes increasingly digital, the need for secure communication is paramount. Qubits offer a solution: quantum-resistant cybersecurity. Quantum cryptography leverages the principles of quantum mechanics to create encryption methods that are theoretically unbreakable. This means that sensitive information, from financial transactions to national secrets, could be transmitted with absolute security. The Quantum Horizon 2025 and beyond. As we venture into 2025, the future of qubits shines brighter than ever. Researchers are constantly pushing the boundaries of quantum computing, developing new algorithms, and building more powerful quantum computers. With each passing day, we inch closer to unlocking the full potential of this transformative technology. The journey ahead is filled with exciting possibilities, and the discoveries we make along the way are sure to reshape our world. Join the quantum conversation. The age of quantum computing is upon us. Qubits are no longer a concept confined to science fiction. They are a tangible reality with the power to revolutionize our world. As we stand at the cusp of this new era, it is our responsibility to engage in a global conversation about the implications of this transformative technology. What new possibilities do you envision for qubits in 2025 and beyond? Share your thoughts and join the quantum conversation. Let us know in the comments below. Thank you for watching Quantum Vision. If you enjoyed this video, please give it a thumbs up, subscribe to our channel, and hit the notification bell so you never miss an update on the latest in quantum computing and technology.